you on what is quasistatic process. See, on the property diagram, say we have this any two properties A and B. When I'm marking a state point, that means I am knowing the condition of the system which is given by these two properties, which is dictated by these two properties. And when am I able to find this state? When the system is in thermodynamic equilibrium. So only when the system is in thermodynamic equilibrium can we get the state, right? Can we know the condition? So getting the thermodynamic equilibrium is very essential, right? When can we get in thermodynamic equilibrium? When the system behaves statically. That is when we can measure the properties. Otherwise, in the dynamic state, we cannot measure the properties which are uniform, which are correct, and which are non-varying, right? In dynamic state, properties will vary, and therefore we cannot understand what is the particular value of property, or even the variation of property cannot be understood properly. So this is when we decided to perform a quasistatic process. So what we did, we had the initial state point because initially the system was static. We even had the final state point because there also, after once the process is completed, then the system comes into rest. So we can mark these two state points. We had no idea about what is the path, what are the state points in between. So what we did, we performed the process very slowly in step-by-step manner, such that we could get the state points which are intermediate, such that we could get all these state points, so that now I can know the path of this process, right? So once I have ample amount of state points, then I can represent this property chart something like this, right? So this is depiction of these state points. I've just represented them by curve. So these were the state points. So now I know between A and B how the path of the process is, and this was enabled why? Because of the quasistatic process. So the important thing to note, to remember, that quasistatic process enables us to get the idealized behavior of the process, and most importantly, it enables us to get the path of the process. Let me take example of expansion process now. What are the different examples? Maybe you have some balloon and you blow air into it, or you have this tire where you during summers this tire expands due to the air present in it expands. So this is again an example, and our classical example of piston cylinder arrangement. Now I want to emphasize on this particular process. Let's take an example of a piston cylinder arrangement undergoing some expansion process. So for this expansion process, let's just consider two properties, pressure and volume. And we know initially the cylinder, the piston is here, and after series of states it undergoes into final expansion, where the volume is V2. Initially the volume was less, it was V1. So I know the initial state of this process, I know the final state of this process. Alright, as of now I have not performed quasistatic process. From this, what information can I extract? I can surely say that I can extract this information, that the process is happening where pressure is some function of volume. Why? Because volume has changed, pressure has dropped. So all that I can comment as of now is pressure is a function of volume, but I don't know the behavior of the system. So for that, what I will do, I will perform the quasistatic process now. Now let's do it with quasistatic process. Now by doing it with quasistatic process, what will happen? Now I know all the state points of the process, right? So now I can define the path of the process, and now I can definitely comment that, okay, by observing I am seeing that pressure is equal to constant upon V raised to some power n, right? So this is what I was able to do once I did the process by quasistatic process. Now you know that the work done for a non-flow system is just the integration of PdV, right? So we have performed this, you must have performed this integration many a times before. But there's a condition here. For this integration to happen, the process must be quasistatic. And why is that so? Because unless the process is quasi-static, you don't know the path and you don't know how is P varying with volume, that we don't know. Right, this is something like this. See, you have any general curve y and x, right? Any general curve. When can you found the integration y dx? Yes, when y is a function of x, right? Y should be a function of x, it should be having a proper path, and it should be a continuous function, right? It should be a continuous function. So here is this criteria satisfying, right? We have a proper path, a defined path, a continuous path, and thus I can easily find out the area under the curve. That is, I can do the integration. That is very simple. All right, but what if I have something like this, y and x, and I don't know the path? I just have initial and final point. I don't know the path. How can I integrate this? So this is similar to what we have in a non-quasi-static process. You will have P and V. You will have two state points, but you don't know the path. What is the path of the process? So if path is not known, how can you integrate this? You cannot integrate this. Integration PdV fails here. Why? Because you don't know the path of the process. There is no continuous proper line. So for that you need to have a quasi-static process. So to have a definite continuous path, the process must be quasi-static. So now once I have performed the process, the expansion process, by following the quasi-static assumption, now I can surely say that suppose P is equal to C upon V. That is what I have found from experiments from this path, right? So now if I try to integrate this, I will do this. Work done is equal to integration PdV. Now I have a proper function of P known, that is P is equal to C upon V. So therefore it will be integration C upon V dV, where C will come out. So it will be dV upon V, and you know this integration is C ln of V plus a constant, right? So to conclude and to summarize what was the important point of this video, to perform mathematical operations on any process, you should ensure that the process is a quasi-static process. And I have in detail told you that why is it so, because once you have quasi-static process, you have path of the process defined, and once you have path of the process defined, only then you can do integration and other mathematical operations on it. So that's it for this video. Thank you so much.